Okay, we're very familiar how to calculate the area of a rectangle or the area of a triangle. We know that we take the length multiplied by the breadth to get the area. And for a triangle, we take the length of the triangle multiplied by the perpendicular height and we divide it by 2 because it's half a square. Those ones we're used to. And then the Greeks and the ancient Egyptians, they wanted to build pyramids, didn't they? Amongst other things. So they wanted to know if they could find any connection between, if we call this side of the triangle A and this side of the triangle B. What will C end up being? And they had a look. And if A was 3 centimeters, and this angle here was a right angle, and this one was 4 centimeters, every time they measured this hypotenuse, and it's called a hypotenuse, the one that's opposite, the longest length of a triangle is called the hypotenuse of a right angle. So the one that's opposite the right angle has always got this special name. Think of hippopotamus. Hypotenuse, the length of the hypotenuse is always 5. And then they made a triangle that's twice as big. They made one with a length of 8 centimeters and a height of 6 centimeters. And then they measured the length of the hypotenuse with a right angle here, and they realized that the hypotenuse was double. So when they doubled the length to 8, and they doubled the height from 3 to 6, it also doubled the length. So they realized that the triangles had similarity. If you double if you double 2 of the sides, you also double the third side. But they still couldn't work out what was the correlation. And then they started to do a few different things. They decided to try, okay, what if we take 3 and we square it? Because 3 plus 4 doesn't equal 5, does it? That doesn't help us very much. And then we take 4 and we square it. So what we're doing is we're taking a squared plus b squared. What do these two give us? Well, 3 squared gives us 9, and 4 squared gives us 16, and 9 plus 16 gives us 25. If I'd squared 5, I would get 25. So they came up with this formula that they call the Pythagoras law that is valid for any right-angled triangle, and it is that a squared plus b squared equals c squared. And this is very useful because 3 plus 4 does not equal 5, but a squared plus b squared does equal c squared. And this very useful thing is, again, is if they give you double the dimensions of the 3 to the 6, or even let's take that this one is 9 centimeters and this one is 12 centimeters. This one is 3 times 3, 3 lots of 3, and this one is 3 lots of 4. So this one will be 3 lots of 5 equals 15 centimeters. So that's very useful as well, because sometimes they try and give you, instead of the 3, 4, 5 triangle is the only one that works perfectly like that. The 3 squared plus 4 squared equals 5. It's the most common one. There is another one actually. I don't know if you're aware of it, but there's one that is 5 and 12. Let's look, what, 12 squared plus 5 squared. A squared plus b squared. 12 squared is 144. 5 squared is 25. Add these two together, we get 169. The square root of 169 is 13. So this one is c squared. C itself must be the square root of 169. So in a 5, 12 triangle, you also get a perfect whole number. So there are special triangles that are like this, but most of them aren't. Let's take an example where we don't have the nice simple 3, 4, 5 triangle. Let's take an example where we say that we have a triangle that is 2 centimeters long and 2 centimeters wide, and we would like to know what is C. Then we'd use our formula. C squared is A squared plus B squared, which in this case is 2 lots of A squared because they're identical. So we'd get 2 squared plus 2 squared, which would be 4 plus 4, which would be 8. So C, when it's squared, will be 8. What will C be then? C must be the square root of 8, which we could change using our theory of surds. The square root of 8 is the same as the square root of 2 times 4, but the square root of 4 is 2. So we could organise that to make it look like that. 2 times root 2. Square root of 2 we know is 1.41. It's an irrational number, so it continues. But we can use this skill to work out what the hypotenuse was. And if they wanted an exact answer here, it would be a calculator question. What do we do then when they give us the hypotenuse on one of the lengths? Well, we just work backwards. Let's say that this is 3 and this is 17. What would B be? We know that A squared plus B squared equals C squared. So if we would like to work out B, we move the A to the other side. B squared would equal C squared. We move to the A to the other side by subtracting A squared from both sides. Whoops, let's put it here instead. Minus A squared to both sides. So we'd get A squared minus A squared. This would give us our 0 that we want. And on this side we'd get C squared minus A squared. So we know that B squared is C squared minus A squared. C squared would be 17 squared and minus 3 squared. Okay, and we could multiply that out, just 17 times itself, 17 times itself minus 9. And then we take the square root of that because we have the square root function in our calculators, and we would get the exact answer for B. Don't forget though, I haven't given any units here. B will be the square root of 17 squared minus 9 millimeters. Don't forget to put your units on when it comes to quoting back what the units, what B was measured in. Okay? So this is Pythagoras' rule. Another thing that they can often do, trying to trick you here, is they can actually give you clock hands. I've seen questions quite often. The clock is at 3 o'clock. So we know that this is the minute hand. And we know that this one is the hour hand. And they could say that this one is, let's say, 4 centimeters, and this one is 10 centimeters. And then they could ask, what is the distance between the tips of the, so you're just wanting to work out C. So you get that C squared is 10 squared plus 4 squared, 100 plus 16, giving us 116. C squared is 116. C is the square root of 116. Sometimes they'll give you an equilateral triangle, like this. And they'll say that, not equilateral, isosceles, so the sides here are the same. And let's say that this side here was 10, and that the base here was 8. And they want you to work out what this height is. You can't use Pythagoras theory here because you don't have a right angled triangle. But if they want you to work out the height, you know that if this is an equilateral triangle, this is 60 degrees, this is 60 degrees, and this is 60 degrees. So you can turn it into a right angled triangle. Take half of it. You know that the C is 10. You know that if this whole length is 8 and you've drawn a perpendicular down, you're cutting this line into two different parts. So that this one must be 4 centimeters. So now you can use Pythagoras theory to work out the height of the triangle. Because you know that h squared plus 4 squared equals 10 squared. And move it for h squared equals 10 squared minus 4 squared equals 100 minus 16 equals 84. And then you can get that h is the square root. Okay, so you can work backwards using Pythagoras as well. So isosceles triangles and also will also help. This, oh sorry, this wouldn't have been, it wasn't an equilateral triangle. The angles wouldn't have been 60. Sorry. The angles wouldn't have been 60, it was only these two lengths that were the same. These two angles would have been the same. So. Okay, and that's how we use Pythagoras rule. So first you square them, then you add them up or subtract them, and then you take the square roots.